Example number 4, solving a permutation problem with conditions. At a used car lot, 7 different car models are to be parked close to the street for easy viewing. So 7 different models. So in part A, it's asking us 3 cars must be parked so that a red car is at each end and the third red car is exactly in the middle. How many ways can these 7 cars be parked? What I like to do is I really love the fundamental counting theorem for these questions because I'm a very visual person when it comes to visualizing these permutations and combinations questions. So I know that a red car must be here, a red car must be here, and a red car must be here. So that means that there are 3 red cars available to me, and so one of them is going to be parked here. And then the next red car, there are 2 options to choose from. Oh, sorry, 2 options to pick from, because of the permutation. And then 1 that's left over. These cars in the middle, that means that there are 4 cars left over. So there are 4 options, then 3, then 2, then 1. So when I multiply all these things together, 3 times 4 times 3 times 2 times 2 times 1 times 1, I have 144 ways. You'll notice that we can write this in permutation notation though, because we have a 3 times 2 times 1, and we have a 4 times 3 times 2 times 1. So what I can actually do is I can say 3 pick 3 times 4 pick 4. I'm just going to highlight these in the numbers, or highlight these in the colors that I used above. And that will still add up to, or sorry, multiply to 144 ways. Whichever way you feel more comfortable with. Personally, I like this because it makes a lot of sense when you actually lay it out. But some people will like this better. Question B. The 3 cars must be parked side by side. So how many ways can the 7 cars be parked? The way that I like to look at this one is that there are no longer 7 slots for cars, but there are slots for the 4 other cars, and then 1 slot for those extra 3 cars. So there are 4 individual cars, so car 1, car 2, car 3, car 4, and then there's the group of 4 cars, oh sorry, the group of 3 cars, so 3, so car 5 is essentially a group of 3 cars. Alright, so in this one, it means that either car 1, car 2, car 3, car 4 can go out, or the group of 4 cars can, or 3 cars can go here. So then there are 5 different options that we can choose from, either one, any one of these. Once we have taken up one of them, we have 4 left over, then 3 left over, and then 2 left over, and then 1 left over. However, in one of these slots is going to be that group of 3 cars. And in the group of 3 cars, they can be arranged in any way. So another kind of like subsection of this question is we have 3 cars and 3 slots. And this option can be either in the first slot, the second slot, the third slot, the fourth slot, or the 5th slot. So essentially what we're doing here is we're saying 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. So the way that we would write this out is either just like this, and we can just at the end of the day multiply all these things together and say it's 720 ways. Or we can say 5 pick 5 times These two symbols are mean the exact same thing. 3, oh, 3 pick 3. We go 5 pick 5 times 3 pick 3. We get 720 ways.